Alright guys, first things first, by this point your conduction, convection, radiation, guided notes should be complete, okay? So this sheet plus this sheet should be complete down here. Everybody should have a different answer, okay? And that just shows me that you're not copying off of someone else, off of me, that you're actually looking at these examples, thinking about them, and creating your own down here, okay? All right, next we're going to go over our methods of heat transfer because everybody is going to be finishing at their own pace, okay? This week's kind of wacky because of benchmark testing, so your class may not have as long as another class, vice versa. All right, so this is going to be straight and sweet and to the point, very, very short. First thing, we're going to define conduction, define convection, define radiation. And we know that define just simply means to state what the definition is. Okay, so by this point, you should be a pro at doing this. All right, there should be no questions. All right, the second part down here, we're going to look at these examples we've been given, and we're going to tell if it's radiation, convection, conduction, and why. Okay, so before you look at any of this, you should have already completed trying to pick what the correct ones are, okay, instead of just copying it down, because that's not going to help you if you're just copying, okay? So a toaster. What happens when you put toast in a toaster and you push the lever down? Heat starts heating up the bread, right? And it's by radiation. Okay, so you've got those electromagnetic waves that this heat is traveling through to warm up my bread, okay? Convection. Remember, convection happens in what two states of matter? Liquid and gas, correct? When I blow dry my hair, I'm not having to hold the blow dryer to my hair to dry it, or my hair would be burnt off, right? It's not radiation, it's convection. So my blow dryer is doing what? Sends that hot air in, blows my hair, it rises. Cool air comes in where? The blow dryer, and it heats up, and it goes right back to my hair, and it's a continuous cycle, okay? Convection. If you got stumped on that one, just think about liquids and gases, conduction, solids, okay? An iron. If I take an iron and I start ironing a shirt, the shirt is a solid, liquid, or gas? Say it's a solid, all right? And my iron is a solid, so solid to solid, direct contact, conduction, all right? These next three, we've got a fire. We've got a heater, a space heater for when wintertime comes. And we've got a little guy at the beach with sunshine. All of these things deal with heat being kind of spread in a let's see, a open space such as outside. And say your living room, and again, you're outside, okay? I'm not touching the fire to get warm. I burn myself. There's not a liquid I'm heating up here. This is radiation. I feel that heat standing away from the fire. So say this is me. I'm warming up my hands. I know I draw really good. But I'm warming up my hands, and I feel this heat by those electromagnetic waves, and that's radiation. Same with this guy. I can sit in my chair, and I can watch football and feel heat because of radiation. Same at the beach. Doing my sun castle. I don't have to go touch the sunshine to get a suntan, all right? When I'm sitting out here, that heat is traveling through electromagnetic waves to me, to the sand, and it's heating up all of this stuff around us, okay? Radiation down here. I've got an oven. We talked about that in our last example. I also have radiation. And if you look here, this has got the pan, okay, in the oven. And it's got little gas coming out. And so it could be conduction, convection, just depending on what you're looking at. So radiation would be me opening up the oven feeling the heat. Conduction would be the pan touching the metal rack right here, and convection would be the warm air rising and the cool air sinking in the actual oven. So it's all happening in there. You just have to look at the different aspects of each so you can know what is what. All right, coffee. We're obviously talking about the liquid end, so the warm air rises, cold air sinks. Remember, your hint here is your liquid, okay? This looks like a pan sitting on top of something heating it up. So for those purposes, we're just going to say that that is conduction. I'm not exactly sure what that is. And radiation would be me feeling the heat off of that guy without putting my actual hand on it, just feeling the heat from around. Okay. When I curl my hair, heat from the curler touching my actual hair. Conduction. Remember, here I go from hot to where? Always. So hot, your heat from your curling iron to your cold hair, curls it. And then here I've got another heater. And what happens is, same thing, hot air rises, cold air sinks, come back in, gets heated up, gets sent back out as heat, okay? So if you need to look over those, listen to me explain it again, go back through the video. This is your time, use it wisely. All right, our next examples. Hot coffee is stirred with a spoon. The spoon gets hot due to, if I've got hot coffee and a spoon touching, I've got two things touching by direct contact, conduction. Okay? A chair is placed several feet from a fireplace. A fireplace has a glass screen. So automatically when I see this, my brain goes through this thinking process that, if I'm sitting by a fireplace, I'm not in the fireplace. And usually that represents radiation. So let me keep going, but I'm going to keep radiation in my head. Okay? The side of the chair facing the fireplace gets warm because of radiation, right? Remember, those electromagnetic waves are being sent out. They're grabbing this heat. They're being spread out to where I can feel it. Okay? Number 3. A certain type of decorative lamp contains colored liquids. Uh-oh. My brain did it again. I see that liquids word. I'm going to keep convection in my head. These liquids form globs that break off and rise up to the top of the liquid. That's almost like my definition of convection because I've got something doing what? Rising. I bet you could tell me if the globs were hot or cold based on our convection definition. Right? So that's convection. Near the ceiling of a room, the air is warmer. The warm air rises, bam, because of, straight definition again, convection. Okay? A college student holds the back of his hand near an iron to see if it's hot. Heat is transferred to his hand by, so that would be like me taking this spoon right here after I had just put it over fire and holding my hand up to it. Not touching it, but just holding my hand up to it. And I would be able to feel the heat because of what? Radiation. All right? Now, here's what I want you to do. For 6 through 17, I want you to make sure you've tried to answer them, okay? And on your own sheet of paper or on the back of this paper would be great. I want you to take the question and go through the thought process of why it is what it is, okay? So here are your answers. Double check, make sure you got them right. Hopefully you got them all right. And when you do that, here's what I want you to do. Look at number 6. A heater is placed under one corner of a waterbed mattress. Warm water moves throughout the mattress because of. Here's what I want you to do. You'll turn to the back and you'll say number 6. And just show me how you're thinking on this paper. The first thing I see is what? Warm water. And water is a liquid. So my brain automatically starts to think convection, convection, convection. Okay? And then it says warm water moves throughout the mattress because of. So then I can really nail down my answer of convection because I see that I've got warm air, or warm water, doing what? Warm air is rising. That means we know that the cold air is sinking, which is why I have convection. Okay? Let's try number 7 as well. A certain type of stainless steel cookware has a layer of copper applied to the bottom to help it heat evenly. Okay, so number 1, I see I've got cookware. Cookware is a solid, right? Think about your pot and pans at home. And I've got copper, which is on the periodic table. And then copper transfers heat to the pan. So I've got copper solid, pan solid. I'm looking at 2 solids, which means I'm looking at conduction, right? And so I go through this thought process. Solid to solid, direct contact is what? Conduction. And then even just to help me, I make this visual image, right? I don't know what copper looks like, right? Most people just don't know what copper looks like, but just draw a picture. So label it, copper. We'll just imagine he looks like this, right? Copper and my pan. And I know that these 2 guys are what? They're touching, okay? And they're transferring heat. And so by that, I know a solid plus solid direct contact equals what? Conduction. And you've got solid plus solid, okay? And that'll confirm what you know, why you chose what you chose, and if it's right or not, okay? So I want you to go through, do the rest for each one of those. When you are finished, you will raise your hand and show me so I can give you points for doing this. All right? If you have any questions, let me know.